In 1963, Let's Make a Deal debuted with host Monty Hall. Contestants see 3 doors. Behind one sits a car. The other 2 hide goats. You pick door number 1. Hall then opens a goat door behind number 3. He offers a switch to door 2. Should you stay or switch? In 1990, Marilyn Vos Savant answered this in Parade magazine. She proved switching doubles your odds from 1 in 3 to 2 in 3. Readers were outraged. When skeptics ran computer simulations, they confirmed her result. The Monty Hall problem flips intuition. It shows probability can defy everyday logic. It stunned the math world. Its lessons echo in game theory and decision-making. It remains one of the most famous brain teasers in probability theory. In 75 AD, Plutarch described Athens' ship of the hero Theseus. Over decades, crews replaced old timber plank by plank. Eventually, no original wood remained. Is it still the same ship? Then imagine rebuilding a second vessel using the discarded planks. Which one holds Theseus' identity? This puzzle probes identity and change. It asks whether gradual replacement preserves something essential. Ancient philosophers debated whether the name tracks continuity or material. Modern scientists revisit it in biology and AI when cells or code get replaced over time. The ship of Theseus forces us to question what makes objects persist. Its simple scenario sparks deep reflections on self and transformation. It influences debates in metaphysics, computer science, and memory theory. In the 4th century BC Greek logician Eubulides posed the heap puzzle. Start with a mountain of sand, undeniably a heap. Remove 1 grain, it remains a heap. Remove another, still a heap. Continue grain by grain. When does it stop? Without a clear cutoff, language shows its vagueness. Call 10 grains a heap, call 200 grains also a heap. Philosophers call this the Sorite's paradox. It reveals how everyday terms resist exact boundaries. Modern logic tackles vagueness with fuzzy sets and semantic theories. Yet the heap puzzle endures. It reminds us that simple questions about how much can have no precise answer. It challenges both linguists and data scientists. It appears in law, engineering, and even digital image processing. Medieval theologians grappled with the question, can an all-powerful being create a stone so heavy that it cannot lift it? If yes, then there is something it cannot lift, so it is not omnipotent. If no, then it cannot create the stone, so it is not omnipotent. Either answer seems to limit divine power. This conundrum first appeared in early Christian writings. Later thinkers like Descartes and Locke debated its implications. The omnipotence paradox exposes the boundaries of unlimited capability. It pushes us to define power clearly. Today, it resurfaces in artificial intelligence. Can an AI program restrict its own functions? The puzzle reminds us that true infinity may be logically impossible. In 1905, Albert Einstein's special relativity introduced time dilation. Imagine identical twins. One remains on Earth. The other blasts off in a spaceship at near light speed. Upon return, the traveling twin has aged less than the earthbound twin. Clocks in motion tick slower than stationary ones. This counterintuitive result emerges from relativity's mathematics. The twin paradox puzzled scientists until Einstein explained that acceleration breaks symmetry. Real experiments with atomic clocks on airplanes have confirmed time dilation. The paradox shows that time is not absolute. It reshapes our understanding of motion and age. Even if you never board a rocket, the twin paradox reminds us that the universe bends time itself. It has practical effects in GPS satellites, whose clocks account for both special and general relativity. In 1960, philosopher William Newcomb introduced a decision puzzle highlighting prediction and free will. A predictor fills 2 boxes. Box A holds $1,000. Box B holds either $1 million or nothing based on the predictor's outlook. You can take both boxes or only box B. If the predictor foresees you taking both, box B will be empty. If it foresees you taking one, box B will contain the $1 million. Rational choice theory suggests you should take both boxes for a guaranteed $1,000 plus whatever is in box B. but the predictor's accuracy tempts you to one box and aim for the million. The paradox forces us to question causality, trust, and rationality. In the 1960s, aesthetics philosopher Kendall Walton asked, "Why do we feel genuine emotion for fictional tales? We cry at tragic movies. We fear monsters in horror films. Yet we know they are not real. How can our minds respond emotionally to impossible events?" The paradox of fiction reveals a gap between belief and feeling. We pretend for entertainment, yet react as if real. Think of Sherlock Holmes's investigations. We mourn his setbacks, despite knowing he is a character. The puzzle touches on imagination, empathy, and cognitive science. It shows how powerful narratives manipulate our emotions. Fiction becomes a mirror, reflecting our deep psychological responses. The paradox informs virtual reality design, gaming, and therapy techniques that harness simulated experiences. Ancient Greek philosopher Epicurus taught that simple pleasures yield happiness, yet he warned, chasing pleasure for its own sake often produces the opposite effect. Direct pursuit of fun breeds anxiety, expectation, and disappointment. Modern psychology confirms that those who fret over feeling happy report less joy than those who pursue meaningful goals. For instance, if you aim to feel good, you monitor your mood and amplify stress. But if you focus on purpose, learning, friendship, creativity, happiness follows as a byproduct. The paradox of hedonism shows that pleasure resists forceful grasping. It pushes us to rethink self-help cliches. True contentment may lie in self-transcendence rather than self-indulgence. In Plato's Meno dialogue from around 300 to 80 BC, Socrates posed a puzzle. How can you search for knowledge of something you do not know? If you already know it, you have no need to seek it. If you do not know it, you cannot recognize it once you find it. Learning seems impossible. Socrates proposed the theory of recollection. The soul already possesses all knowledge, and learning is merely remembering. Critics argue this raises questions about innate ideas and evidence. The paradox of inquiry challenges assumptions about how discovery works. It underlies scientific methodology and highlights the dilemma of hypothesis testing in research. In 1924, mathematician David Hilbert illustrated the oddities of infinity with an imaginary hotel. The hotel has infinitely many rooms, all occupied. When a new guest arrives, the manager asks each occupant in room to move to room N+1. Room 1 becomes free, and the newcomer checks in. Then a bus with infinite passengers arrives. To accommodate them, he shifts each guest from room N to room 2, N freeing all odd rooms. Despite being full, the hotel always makes room for more. This thought experiment reveals that actual infinities defy finite intuition. It influences set theory and cosmology, where infinite sets behave in surprising ways. It also sparks debates about infinite resources and the nature of the universe. Time travel stories give rise to the bootstrap paradox, where objects or information loop from future to past with no clear origin. Imagine you travel back with Beethoven's unpublished sheet music. You publish it under your name before the composer ever writes it. Later, Beethoven finds your publication and claims it as his own. Who actually composed the music? The effect becomes its own cause. This closed time loop paradox breaks causality. It first appeared in science fiction tales and philosophical essays. It highlights the contradictions of time loops and predestination. The bootstrap paradox reminds us that some scenarios may amuse the imagination yet defy logical consistency. Scientists and writers use it to explore whether time travel could ever be coherent. Also, in Plato's Meno, Socrates sharpens the inquiry puzzle into what became known as Meno's paradox. If you do not know what virtue is, how will you recognize it when you discover it? If you do, there is no need to search. Socrates resolves this with the doctrine of anamnesis. Learning is recollection of innate knowledge. He demonstrates with a slave boy, guiding him to solve a geometry problem without prior instruction. Yet invoking innate ideas raise debate. Where did the knowledge originate? Meno's paradox probes the origins of understanding itself. It remains central to epistemology and cognitive science, questioning how the mind grasps new concepts. Its implications echo in modern debates on nativism and constructivism in psychology.